Welcome to lesson 4.7, drawing circle graphs. So in the previous lesson, you have learned what a circle graph is and the different components of it and how to read and interpret that data from a circle graph. And in this lesson, the focus is learning to create and construct circle graphs to display information and different types of data. So before we get started, the picture on your screen, this is called a percent circle, and essentially it's a circle that's divided into 100 congruent parts, and if you recall, congruent means equal. So if you see each one of those little dashes or lines represents one of those 100 pieces. So if you count the little congruent parts within each sector, what I mean is how many of these individual lines are there in one sector. I can count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So within each sector of this circle graph, there's 10. I'm just going to write this down. There's 10 of those congruent pieces, or those little parts. So each section represents 10 of 100 because we know 100 represents our whole. And in each section, there's 10. So 10 out of 100, so each section represents 10%, or 10 hundredths, or 0.10. Again, it's just the relationship between fractions, decimals, and percents that we learned in the last unit, just to draw your attention. So essentially what I'm getting at, each of these pieces represents 1/10 of your circle graph, or one whole. Therefore, 2 pieces would equal 2/10, or 20%. 3 pieces would equal 3/10, or 30%. 5 pieces would represent 5/10, or 1/2 of your circle graph, or 50%. 9 pieces would represent 9/10, or 90% of your circle graph. So again, it's just using those numbers and becoming really familiar and comfortable with the relationship between a fraction and a decimal and percent, especially when they're in their tenths, because those are easy kind of numbers to deal with. So I will photocopy these circle graphs for you for class when you get to lesson 4.7, so you can draw your circle graphs on this. So you are as precise as possible when constructing them. When you get into the 63%, you know each of these represents 10%. So if I have 63%, let's just do this as an example. Oops. If I want to color in 63% of this circle graph, if I know that each section, let me just color this in, represents 1/10, or 10%, like we went through before, this would equal 20, 30, 40, you're going to color yours in a little bit better than mine, 50, 60. If I wanted 63%, then I would have to count 1, 2, 3 dashes, and with a ruler I draw a really straight line, and then I could color that in. So I know that this whole section of my circle graph now represents 63%. If I wanted to, in a different color, 12%. So if I want to represent 12% on this same graph, I know that that's 10, 1, 2, and with a ruler I draw a really straight line to the center, and now you can color this whole section in, and that would be 12%. What is left over if I'm only splitting this circle graph into 3 sections? I have one section that represents 63%, one section that represents 12%. What percentage does this represent? So you could figure that out one of 2 ways. I could look at these numbers, add them together, and then go 100, subtract that number being 75, 63 plus 12 is 75, and then what's left over is 25. So we know that this section of our pie, which I would need to draw in a different color, would represent 25%, or 25 out of 100. And I could also figure that out. I could just count each of the little dashes from there to there, and I would count 25 dashes. So again, I would know that it's 25 over 100, or 25%. So in a nutshell, that's how you use a circle graph, and that's how you represent some sort of data. On the next slide, we're going to go through one example of how to look at data and construct the graph and figure out the percentages for a set of data or a set of information. Okay, so let's read through this example together, and I'm just going to underline as I go because that helps me keep track of important information. So, all of the students in 2 grade 7 classes were asked how they get to school each day. Here are the results. So 9 students rode their bikes, 11 students walked, 17 rode the bus, and 13 were driven by car. And so our question says to construct a circle graph to illustrate these data. So our first thing is, okay, well, we know that 9 rode their bike, 11 walked, 17 rode the bus, and 13 were driven by car. So now what? How do I represent that information in a circle graph? And remember, circle graphs show percentages. So our first thought that's going through our head is we need to somehow get this data and turn it into a percent. And what do we know about percentages? Percentages usually start as a fraction, or they're usually start as being represented by a fraction. So I'm just going to write out my data in a little bit of a different way. So I know that 9 students rode their bikes. I know that 11 students walked, 17 rode the bus, and 13 were driven by a car. Now these aren't fractions, these are whole numbers. What we need to think about is what is the whole, or what is kind of the 100%? What is the value for all of the students? Because our question says all of the students in 2 grade 7 classes were asked how they got to school each day. So 9, 11, 17, and 13. When I add all of these numbers up, it equals 50, and that tells me the whole value of the 100% of students. This tells me how many grade 7 students were asked about this information. They were asked how they got to school. So now we can use this 50 representing our whole, or our 100%, to create some fractions. So 9 out of 50 total students rode their bike. 11 out of 50 total students walked, 17 out of 50 total students rode the bus, and 13 out of 50 total students were driven by a car. So our next step is to turn these fractions into a percentage. So if you recall from last unit, Unit 3 on fractions, decimals, and percentages, what is the process of doing that? So I have my 4 fractions, 9 50ths, 9 out of 50, 11 out of 50, 17 out of 50, and 13 out of 50. Remember that a fraction just represents the operation of division. So this represents 9 divided by 50, 11 divided by 50, 17 divided by 50, and 13 divided by 50. In order to turn a fraction into a percent, we need to find its decimal and then multiply by 100. We did this in our last unit. So let's do that. I'm just going to get a different color here. So 9 divided by 50 as a decimal is 0.18. When we multiply that by 100, we get 18%. 11 divided by 50 equals 0.22. Multiply that by 100, and we get 22%. Let's not forget our units. We always need our unit on there. 17 divided by 50 is 0.34. So that's it as its decimal, but we need its percentage, so we need to multiply that by 100. So we get 34%. And our last one, 13 out of 50. Our decimal is 0.26. We multiply that by 100 to find its percentage, and we get 26%. So we've now found all of our percentages that we're going to represent on our circle graph. So our first step is done. So now that you've figured out the percentages for each method of getting to school, it's now time to start constructing your actual circle graph. And there's two ways you can do this. One way with the percent circle, like we just talked about, and another way is using a protractor to actually measure the angle, and we'll talk about how to do that on the next slide. But I will have the percent circles available for you in class for you to use, but I would like you to know both methods as well. So the first thing we always need in a circle graph is a title. And so what is this circle graph representing? It's representing how students got to school each day. So how students get to school. So you're going to give your graph a title. Yours is going to be much neater than mine is. And now we need to start plotting our percentages into our graph. Remember, each section needs to be labeled and it should be a different color. So if I look at bike, and we'll start with blue, and I see that's 18%. I know that each sector of my circle represents 10%. So if I color in that one, and then I need to go all the way to 8 pegs, and again, it's a little bit hard drawing on this program. You guys will be much more accurate than me. But I'm going to count 18 of the little dashes, and that will represent 18%. And remember, you always need a legend or you need to label, so I'll just make a quick legend over here saying that blue represents bike and that it represents 18%, because we want to make our data as clear as possible. So our next one is walking, 22%. So again, I'm going to do exactly the same thing. And I'm just going to count 22 spaces, knowing that each sector represents 10%. And I'm going to color that in. We're not leaving any space in between each section because we know when we add up our 18, our 22, our 34, and our 26, that's going to equal 100%. So all of these dashes will get filled up. So I've colored in my next section, 22%. And nope, yeah, I did. So green represents walking. And it represents 22%. So I'm going to go on to my third one. Bus is 34%. So 10, 20, 30. Then I need 4 dashes. 1, 2, 3, 4. Draw a nice straight line to the center. Color this section in so we know that represents 34%. Add it to my legend. Bus. And 34%. And then our last one, I just need to get one different color here, to purple. Car is 26%, so it's going to be whatever's left. You would double check just to make sure and count all those little spaces. But because we know that all of these numbers added up will equal 100%, I know that it's going to take up my whole graph because there's 100 dashes in it. And our purple represents car, which is 26%. So that's the first method, using the percent circles. It's kind of the easier method to use of the two because your circle's already measured out for you and it's already sectored off for you, so you just need to count the dashes. The second method that we're going to do is, I'll kind of have to give a little mini lesson on it in class, but it's using a protractor and it's figuring out the specific degrees or angle that you would have to measure out for each section. So we'll do that one on the next slide. So the second method is to find what we call the sector angle for each bit of information or data you have here. And the sector angle is the actual degree or the measurement in degrees that you need to use a protractor to measure it to display each type of data. And so how we find the sector angle is by multiplying each percentage, each bit of data that we have, by 360 degrees. And you might be asking, well, why 360 degrees? What do you know about that measurement of degree? Does it ring a bell? Do you know something about it? Hopefully at this point, you know that 360 degrees is the measurement in degree of a circle. That's how many degrees are in one circle. So we're multiplying our data by 360 degrees. So it gives us a very precise measurement in degrees that we would measure out to plot our data. So again, if you recall back to last unit, you don't multiply numbers by their percentages. So we need to kind of take a step backwards and turn these numbers all into their decimals and then multiply by that 360 degrees. So 18% is a decimal, 0.18. Multiply that by 360 degrees. And that equals 64.8, but I'm just going to round it up to 65 degrees. Walking, 22%. We're going to change that to a decimal, 0.22. Multiply that by 360 degrees. That equals 79.2 degrees, but we're just going to round that and keep it at 79 degrees. Bus, 34 as a decimal, 0.34. Multiply by 360 degrees. That equals 122.4. We're just going to round that to our whole number, which is 122 degrees. And then a car, 0.26. Multiply by 360 equals 93.6, and we're going to round that up to 94 degrees. So what these degrees, and I can't show you on an electronic program, so this is where a mini lesson in class will come in handy, but essentially these numbers, this is not a percent, it's a degree. These numbers represent the measurement of a protractor that you would need to use to represent each method of transport. So using a protractor, I would measure out 65 degrees. And again, I'm totally eyeballing it. I do not have a protractor in front of me. I will show you how to use a protractor if you don't remember how to use it from last year. If you recall, your protractors are the little semicircles. They have all the little dashes around, and it measures angles from 0 to 180 degrees. Does that sound familiar? I hope it does. If you forgot how to use it, I will gladly show you in class. But you use your protractor to then measure out, okay, 65 degrees. So you know that that would represent 65 degrees right there, and that represents the piece of the circle graph for a bike. And then I would need to measure out 79 degrees with my protractor. And again, my measurements are probably way off here. 79 degrees measured on my protractor would represent people that walk. And then I would measure out 122 degrees using a different color. And I would color that in. And that would represent people that take the bus. And then I would measure out 94. Again, I'm not even close here with my measurements. I just know that's why you need a protractor, so you can be very precise. And that 94 degrees would represent people that take a car. And so if you flip back to the last slide or just rewind a bit, the size of your circle graph will be exactly the same as the size in the previous one. It's just two different methods. One is using your protractor to measure degrees, and one is just using the percent circle, which is already measured out for you. So that's it for the lesson today. So if you have any questions, please come to class with them. Otherwise, you can move on to the practice questions for this section, which is the last section in Unit 4. Thanks for watching.